Hi algebra students, this is our introduction video for our lesson on equivalent quadratic expressions. This lesson is really going to focus on how you can change quadratic expressions that maybe are in factored form into equivalent equation or equivalent expression in standard form. So let's start with that vocabulary that I was just using. Standard form is going to be any quadratic expression written in the form that I've given you in previous lessons. The form ax squared plus bx plus c. I love examples when I'm talking about different forms. So examples could be some of these we've seen in the past. Things like 200 minus 16x squared, or expressions like x squared plus x plus 1. Those are our standard form. Factored form is going to be newer to us. Factored form is going to be any quadratic expression written as a product. And we've learned that word product means we're talking about multiplication. And so, for example, in a previous lesson we saw this expression here. This would be in something we call factored form because it's written as a multiplication problem. We're multiplying x by 18 minus x. You might also see things like this. This would also be factored form because we have it written as a multiplication problem. X plus 3 multiplied by x plus 4. So our focus in this lesson for today is going to be changing different expressions that are in factored form into standard form. This first one here you have already done in previous lessons. Go ahead, pause this video and see if you can use multiplication and distribution to help you change that into standard form. So the way to change this expression here into standard form is using distribution. We've learned if you have something in front of parentheses like this, it means you are multiplying 4x by 2 and 4x by that negative x there. When you do that, 4x times 2 is 8x, and 4x times that negative x there is minus 4x squared. X times x is x squared. That's going to be super important for what we're doing today. This expression here, there's nothing else I can do. You can't subtract an x and an x squared because they have different exponents, and so that would be our final answer. That is our standard form. Now, expressions like these we've seen in previous lessons. This one here for b, though, is a little more new to us, where instead of just having one term we're multiplying, we have two terms, that 4 and the x, that we need to multiply by x minus 3. When you have bigger expressions like these, there are two ways you can approach the problem. One way is using distribution similar to what we did in A. The other way, though, is drawing this diagram that helps you see all the multiplication you need to do. So I'm going to do this problem two ways, and in today's lesson you can decide which way you like more. When we're doing this multiplication problem, you can use a diagram like this to help you see all the multiplication you need to do. For this problem, I need to multiply 4 plus x by x minus 3. So each set of parentheses I'll put on one side. 4 plus x I'll put over here, so 4 and then a positive x. And then that x minus 3 I'll put on the other side. X and then the negative 3. I'm going to divide this rectangle into each of the parts. So 4 and x, those are two different terms, so I'm going to separate it into two parts. The x and the negative 3, that's also two terms, so I'm going to separate it into two parts. And there are 4 squares now, and each square represents the multiplication we need to do. This square here is telling me I need to multiply 4 by x. And so 4 times x, that gives us 4x. This next square right here is telling me I need to do 4 times negative 3. And so 4 times negative 3, that's going to give me negative 12. Go ahead and see if you could figure out what are the two other multiplication problems we need to do. For this square, I need to do x times x, and x times x is x squared. For this final square, I need to do x times negative 3, and x times negative 3 would give me negative 3x. The people who like this diagram are people who really feel like they're visual people. I really like it because you can see there's 4 multiplication problems you need to do, so you don't forget any, and you can see based on the sides of the diagram what the things are you need to multiply. After this, I'm just going to pull out all 4 of those answers and put them all together for my answer. This is telling me if you were multiplying all this out, you have 4x minus 12 plus that x squared minus 3x. So this is one way you can do the problem. The other way you can do the problem, though, is using distribution like we did in that first problem. The only difference here is because there are 2 terms in front, the 4 and the x, you have to multiply twice. You have to distribute 4, so you have to do 4 times x and 4 times that negative 3. But you also have to distribute x, so you have to do x times x and x times negative 3. Sometimes when you're trying to do this multiplication, it's harder to see what you need to multiply. So I always do it like this, where my 4, I'm putting those arrows on top, and then the x, I'm putting those arrows on the bottom, just to make it a little easier to look at. If you choose distribution, you're going to do all of the same multiplication we already did here. So I'm doing 4 times x is 4x. 4 times that negative 3 is negative 12. And then I distribute my x. X times x is x squared. And x times that negative 3 is negative 3x. Notice we have the same answer. So no matter if you use the diagram or you decide you like distributing, you get the same result. Now the only thing left for us to do for both of these is we always need to simplify. And so looking at those expressions, can you tell what we can do to simplify these? There's 2 terms we can combine. I can combine 4x and minus 3x because they have the same variable and the same exponent. So my final answer for this, I would want to say 4x minus 3x gives me 1x, or that is just x, and then I need to copy down everything else. Usually when you have stuff in standard form, you'll see that x squared term first, your x term second, and your constant, the number without a variable, third. So you'd see it like this, but please know that you could have also written x minus 12 plus x squared. This is okay too. In today's lesson, we're going to do more problems like this, and by the end of the lesson, you'll hopefully know which way you like more to do these problems. Thanks so much for watching. You are ready for today's lesson.